Jai Jinendra, Namaste and welcome to my channel. Today we are going to solve the 94th question of the problem solving series and the 4th question of the topic tree. Invert binary tree. The difficulty level for this question is easy and this question has been asked in Google, Amazon, Microsoft, Adobe, Apple and Oracle and many other companies. Let's look at the example. So we are given this binary tree and we need to invert it. Okay. By invert we mean that for this tree which starts with this root node 4, we want the left subtree to be interchanged with the right subtree. So whatever value we have in the left part of this tree, that will interchange. So starting with this 4, we see, go to the left and right, we see 2 and 7. Okay, so this 2 and 7 will interchange. So firstly this whole thing will interchange. Okay, so this full thing should come over here. Okay, so here if we are here at 4, so we will bring this whole thing 7, 6, 9 and 2, 1, 3 here. Okay, so now after that, since we have interchanged, now for this one, this two value will interchange. Okay, so every nodes left and right subtree will interchange with each other. So this 7 and 6 and 9 will interchange to 9 and 6. Okay, and then this 1 and 3 will interchange to 3 and 1. Okay, so in this way we will invert. We will make the left subtree interchange with the right subtree of the root part. Now how do we do this? So firstly you need to see that if the tree starts with null, if we do, like when we will end like we know that a tree is a hierarchical data structure, right? So obviously we have to do it recursively, because whatever happens for this has to be happening for both the left and the right part, right? So the termination condition would be that, okay, if the root is null, so you need to first think of the termination condition. So if the root is null, then we will return null. Okay, now what should we do? If we see that we are at the node part, okay, so we go to the left part and we go to the right part. So one node is here and one node is here. Okay, now here, once we are here, then if we interchange its value from 2 to 7, right? So we can interchange its value from 2 to 7. So this 2 becomes 7 and this 7 becomes 2, right? No problem. Now if we do that for here also, we need to interchange. This whole thing has to interchange, right? So instead of changing the values, we have to change the pointer itself. So this whole pointer would change actually. So if this 4 is here, this whole thing will come over here and this whole thing will go over there, right? So we'll interchange this whole pointer, right? If we interchange this one, this will bring back its 6 and 9, because its left is 6 is 9. So this whole thing will come here and this whole thing will go here, right? Now we will go to this down part again, right? So after we change this 4 2 7 1 3, right? We are here now and our one pointer is here, right? 2 1 1 3. Okay, so we did it for this one. Now we are here. Now we need to do it for this thing. Okay, it's left and right. This has to interchange. So since it doesn't have any left and right subtree, so this whole thing will come over here, and this also doesn't have any left and right subtree. So this 3 and 1 will come here, and since it doesn't have, this part will exit. It doesn't have any child. Same will happen for this 3 and 1. So what we are doing, we are interchanging the pointer. So we have seen how did we interchange two values, right? When we are given, if you would have solved in array also, right? When we are given two numbers, you need to interchange by taking a third variable, right? So we interchange. Similarly, we'll interchange this pointer, this whole thing, okay? This tree, this subtree and this subtree will interchange, okay, when we are here. So let's do it. What is the base condition? So what we'll do, we'll call a function mirror that makes the mirror image of this one, right? So we call a function mirror and we pass this root, and then we'll code this root. After when we call this mirror function, this would do the invert operation, and then we will return the root node. Okay, So let's code the mirror function. So mirror would be a void function, right? Because we need to change the data type. If we can't make it a recursive because it will return every time value, right? So we'll call a void mirror function which has this tree node, tree root. Okay. So if root is equal to null, what do? We return. Okay. Else what we do? We take a temporary node, tree node strict temp, and what do? We will call the mirror will pass the left pointer. Okay, mirror root left and mirror root right. Okay, because we need to do the operation for both of them, right? So this node and this node, both of them has to be done. So whatever change that we are doing, we will be doing it here at this part, else. Okay, here in this part. After calling this, so once we are called, we are at the bottom here. Okay, that from we will start the change from the down, right? After doing the change from the down only we go up. That would make sense, right? So it would be a bottom up approach. So we are gonna we'll change it from the bottom. So once we are done here, now we'll take a temporary pointer tree node strict temp. Okay, because that point of time we'll have both the pointers to change, right? When we are here mirror root left and root right, we have both the left and the right pointer now. Okay, this pointer and this pointer. So tree node strict temp. So if you have any problems about the recursion, how we do this, I've already taught from 56 to 60. You can solve those questions of 4 or 5 questions of recursion, and then you can see this how this recursion actually works. So tree node strict temp. So now what we'll do, if temp is equal to root left. Okay, we are storing the root left pointer in temp, and then we will make root left is equal to root right. Okay, and then we will make root we have stored root left, right, and we'll make root right is equal to temp, which contains root left value. Okay, so this interchange we have done, and this will make the inversion. Okay, so let's look at the example. So if in this case 4, we call this mirror 4. Okay, then it goes here, it is not null, so it comes to the else part. Okay, after, so this one I can remove, this is not required. Else we go to the mirror root left, we call this root left 2. Okay, this is also not null, so this goes again, here comes, it comes here, again we call root left, so 1. Again when it is called root left, it returns, it just returns. Okay, doesn't give any value. So I have this 1. Here also in this case I have this 3. Okay, because we can't go more bottom, right? It ends here. These are null. So now we have this root left pointer as 1 and root right pointer as 3 at the end, and then we'll interchange this value. So this 1 and 3 will become 3 and 1. Okay. Now once this is done, then it will go up here, and meanwhile for this one, this interchange will happen 9 and 6, and now we'll have 2 and 7, and this interchange will happen. After this 7 will come over here, and this will come over here. Okay, so this will not come like this, 7 and 8. So once 2 and 7 is there, this whole thing will come. So this 9 and 6 is there. Since this has been changed, now this contains this child. Okay, so this whole thing will actually shift over here, because it has this left and right. That's why we are starting from the bottom. We are making the bottom change, because when we go to the upper part, the whole thing will be shifting. That's why you need to start from the bottom. That is the logic. Okay, I hope you have understood this recursive function. And this question, the link to the question is given in the description. Please try it yourself and then come to my code walkthrough section. Here's the code walkthrough of the 94th question of the problem solving series. Invert binary tree in the lead code platform. You can see the difficulty level is easy, and this question has been asked in these companies. Okay, so you can see this example 4 2 3. This before at the first we'll change the leaf nodes will be interchanged 1 3, it will become 3 1, and then 6 9 would become 9 6, and then it would go over there and we'll make the whole change here. This 7 and 2, this will come over here, and then this 7, once it comes over here, this is becoming like this 4 7 9 6 and 2 3 1. Okay, so let's look at the code. We call this mirror function, and then if node is null we return, otherwise we go to the left and the right part, and at the end we change this pointer, so starting from the leaf bottom up approach. And so let's submit this directly. So it has passed, and yeah, I think hope you have understood this question. See you also in the next video. I'll be explaining the 95th question of the problem solving series. Jai Jinendra.